Hi Math 2 students! Today we're going to go and work through the 6.9 Day 2 notes. We're not going to finish all of them in this video because there's quite a lot of problems, but we're at least going to get started on them. So first we need to learn about two different terms. We have angle of elevation, which is the angle formed with the horizontal as an observer looks upward at an object. So you're probably like, what's going on? So we're going to be doing word problems, and we're going to be drawing right triangles to solve them. And angle of elevation would be like if we had a girl looking up at a plane. So let's draw a girl, and oh boy, that's my plane. Our angle of elevation would be this angle here, okay? If we had a man looking up at a tree, this is our man. That's our tree. This would be our angle of elevation. All right. Now, the angle of depression is formed with the horizontal as an observer looks downward at an object. So a boy viewing a boat from a lighthouse. So we have, oh boy, let's see. An attempt to draw a lighthouse. I don't know. That looks terrible, but that's where our boy is. And he's looking down at a boat. Okay, so what ends up happening is this is the angle of depression. However, it's important to recognize that the angle of depression and the angle of elevation actually kind of end up being the same thing because these lines are parallel. All right, so these guys are alternate interior angles. So you end up with them actually almost being the same thing. So you have to understand where the angle of depression comes from, right? It's going to kind of come from the top because you're looking down. But then you can draw that angle in there because of alternate interior angles. Let's see. We had a woman spotting a fire from a cliff. So let's draw she's on a cliff. And there is a raging fire. So this would be your angle of depression. And you can, of course, reflect it there. So kind of keep that in mind. We'll be referencing these beautiful pictures of art that I drew here. So let's go ahead and try some of these problems. All right. Now, it says, set up and solve the following problems. Include a diagram. This I am going to emphasize so much. As you can see, I am not good at drawing. However, when you do these problems, you have to draw pictures. It's not optional. I want you to actually draw in. If they say a person's looking down, draw a person. If they say there's a tree, draw a tree. If there's a boat, draw a boat. It really helps with trying to visualize what they're trying to describe. So for number one, it says the angle of elevation from a point 59 meters from the base of a flagpole to the top of the flagpole is 27 degrees. Find the height of a flagpole. So let's go ahead. I'm going to draw my flagpole here. All right. Oh, I wasn't supposed to do that. So that's our flagpole. And they said we've got an angle of elevation. So we're going to draw our triangle. And this is our point. And the angle of elevation is going to be here. All right. So that's the angle we're looking for. They want us to find the angle of elevation. And, oh, actually, no, they gave us the angle of elevation. They said it's 27 degrees. All right. Then they tell us that this point is 49 meters from the base of the flagpole. The base always means like the bottom. Think base, bottom. So the distance from the bottom to this point is going to be 49 meters. And they want to know the height of the flagpole. So the height of the flagpole is going to be this guy. So that's going to be our unknown. We'll put our X there. So now we've got our picture drawn here, and we've got a right triangle. So we're going to use SOHCAHTOA to solve this. So if we have to look at which sides I was given in relation to my angle. Well, I was given my opposite side. This guy's my hypotenuse, but I wasn't given him. And this guy's my adjacent. So I'm going to need tangent. So I'm going to do tangent of 27 equals my opposite over my adjacent. And then, of course, we can cross multiply. You get 49 tangent of 27 equals x, and we can go to our calculators. 49 tangent of 27 is going to give us 24.9 let's see, they want us to round to the nearest hundredth, so 2 decimal places. 24.97, and then the units on this is meters. So the height of the flagpole is going to be 24.97 meters. All right, let's draw another picture here. It says a 15-foot ladder is leaning against a house, and it makes a 52-degree angle with the ground. How far will the top of the ladder be above the ground? So let's draw a picture. We're going to draw our house. Beautiful house. And then we're going to draw our ladder. Right, it's leaning against the house. So we've got our triangle here. They tell us it makes a 52-degree angle with the ground. So we're going to put 52 here. And then they tell us it is a 15-foot ladder. So that means that the ladder itself should be 15 feet. Right? And it says, how far will the top of the ladder be above the ground? So they're talking about this distance here. This is the top of the ladder. That's my ground. That's my unknown. So if we look, I was given my opposite and my hypotenuse. So which trig function am I going to want to use? I'm going to want to use sine, right? So we're going to do sine of 52 equals my opposite, which is x, over my hypotenuse, which is 15. Go ahead and solve for the height. So to solve for the height, we're just going to cross multiply. We get 15 sine of 52 equals x. And we can go plug that into our calculator. And we get 11.82. And then this is going to be in what, meters? Feet. All right, let's try another one. If an airplane takes off at an angle of elevation of 21 degrees, if the plane travels for 10 miles during this initial ascent, how high off the ground will the plane be? If a train travels for 10 miles. The plane travels. You know, I'm going to be honest, this one, I don't know if the 10 miles should be the hypotenuse or the base. So I'm going to get back to you guys on that one. Let's skip number 3. I feel like it should be the hypotenuse, but I'll do that one in class with y'all. All right. And then let's see, let's do number 4. So from a 40-foot observation tower on the coast, a Coast Guard officer sights a boat in trouble. The angle of depression of the boat is 3 degrees. How far is the boat from the shoreline? So we need to draw a picture here. We have an observation tower. I'm going to draw my tower. Beautiful, right? They said it's 60 feet tall. So this guy is 60 feet. And he spots a boat in trouble at an angle of depression of, of 3. So let's draw our triangle. My angle of depression is 3 degrees, which by alternate interior, we know that this is also 3 degrees. And they want to know, and actually the 60 really shouldn't be inside the triangle. I don't like doing that. So the 60 here is the height. How far is the boat from the shoreline? So the shoreline is down here, right? This is here. So we're trying to find this distance. That is our unknown. So we are given our opposite. We are given our adjacent. We're going to need tangent. So we're going to do tangent of 3 equals our opposite over our adjacent. So go ahead and solve for x for me. So to solve for this one, we have to cross multiply. We get x tangent of 3 equals 60. And then we end up having to divide. So we get that x equals 60 divided by tangent of 3 degrees. So let's go plug that in. And we get 1144.87 feet. So hopefully you're kind of starting to get an idea of how you set these up. Basically, you read the problem, you draw a picture, and then you go ahead and have to figure out what they're asking for, and you solve for that.